Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the volume and surface area of pyramids and cones. What makes these different from the prisms that we've looked at for the last few lessons is that these shapes taper off. Rather than, say, having a square at the bottom and the top, you can see that it tapers off, converges to a point. Similarly for a cone. A cone has a circle at the bottom, but it tapers off, unlike a cylinder. So it turns out the volume of a pyramid or cone is just a third AH. It's just the area of the base times the height divided by 3. And it was figured out a long time ago that each of these has a volume 1/3 of their respective prisms. So this here is like a rectangular prism with dimensions 10, 10, and 12. Its volume is exactly 1/3 of that rectangular prism. Here, this volume would be exactly 1/3 of a cylinder that had diameter 4 and perpendicular height 6. So let's go through and calculate the volume of these two shapes. It's pretty easy. It's just the area of the base. So for the square pyramid, it's 10 by 10. So that's the area of the base. We times it by h. H is always perpendicular height. And then we divide it by 3. So we get 400 meters cubed in this case. So this could hold 400,000 liters of water. For this shape here, it is the area of the base. The area of the base is pi times radius squared, not diameter squared, and then multiplied by perpendicular height. But once again, you must divide it by 3. So putting that on our calculator, we get about 25.13 meters cubed. All right, that's all well and good for the volume. Now we'll look at the surface area. So I'm going to rub out these calculations. Please pause and copy down if you need. So to find the surface area of any solid, including pyramids and cones, we just find the area of each of its exposed faces and add them together. So for this shape here, the total surface area is going to be the area of the square at the bottom, and then we're going to add the triangles. There are 4 triangles here. Now, to find the area of, say, this triangle here at the front, we need to know the perpendicular height of the triangle, not the perpendicular height of the whole prism. So to do that, once again, we're going to need Pythagoras. So we've got this dimension's 12. Here is half of the length of the square, so it will be 5. And that means this side here will be the square root of 5 squared plus 12 squared, which is 13. So the perpendicular height of this triangle is 13. Because this is a square, each of the 4 triangles will have the same area. So the total surface area is area of the square at the bottom, plus there are 4 triangles. Each will have area base times perpendicular height over 2. So putting that in our calculator, it will be 360 meters squared. All right, let's now look at the surface area of a cone. So a cone, it turns out, has a sector plus a circle. So all we need to do is add up the areas of these two shapes. Well, clearly, the area of the circle at the bottom, we actually found it when we were finding the volume, it's just going to be pi times radius squared. So it turns out the area of this curved surface, this sector, the lateral surface of the cone, is pi rs. So it will be pi times radius. Now s is actually the slant height here. So you don't need the slant height to find the volume, but you absolutely do need it to find the surface area. So once again, we need to use Pythagoras in order to find out what it is. So we have 6. This length here will be 2. The radius is always half the diameter. So S will be the square root of 6 squared plus 2 squared. Now that actually equals the square root of 40. So in my calculation, I'm going to use square root of 40 because that's exact. I'm not going to round this because then my next calculation will be a bit inaccurate. So putting that all on the calculator, we get that it is about 52.3 meters squared. So once again, we calculated these surface areas assuming the shapes were closed. We wouldn't say add this circle if the cone was open, if it didn't have a top or a bottom. So just make sure that when you're doing such a question, you know whether the shape is open or closed. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.